Hey, welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be picking up right where we left off in the last, which is talking about gizmos and debug stuff. Specifically more of the gizmo stuff. We pretty much covered all the debug stuff. Right, so getting right back into it, we had all of these, we have our debug messages, we have our lines, and now we're going to be talking about gizmos. Gizmos are kind of an intense topic, as I mentioned at the end of the last video. But the easiest way to describe them, describe how they work, is just to kind of just show you. So I'm going to jump right in. There are a couple functions that we need, like update and like start, which I removed at the end of the last video. We didn't really need it. We're not going to need it, I don't think. They're, I guess, inherited functions. So they're on draw gizmos and on draw gizmos selected are the two we're going to be using. So on the first one, it's going to be void on draw gizmos. Yep, just like that. Alright, so this is called naturally through Unity on every object that has it. It's kind of a global send message to everything. It just runs all the C# scripts with this on it. Stuff that we put in here will draw, depending on what kind of thing we're doing in here, it will draw the gizmos that we need. Okay, there's a gizmos class, and in here it was basically everything we're going to be using for this example. There is gizmos.drawMesh, and I believe there is draw icon, so we can even supply icons and things like that. That is things that we can do. That is things we are not going to do. Right now, we're just going to be covering frustrums and all sorts of stuff. All right, yeah. We're just going to be covering basic shapes. We're going to be covering cubes and spheres, and the two different kinds that there are. I could be here for a very long time if I wanted to cover all of this. These all pretty much behave the same anyway. I mean, if you understand how a mesh works, this makes a lot of sense. But if you understand how icons and stuff work, then this makes a lot of sense already. Like, I don't understand quite what the name is. I think the name is like the name of the icon in editor, like in the inspector and stuff. So that's kind of weird, but anyway, point is we're not going to be covering any of that stuff anyway. So if we wanted to change the color of gizmos, we would say gizmos.color. And we're going to make this equal a color.red. So that's how we change the color of gizmos. Every time we want to change the color on a gizmo, we have to set what the gizmo's color is. So we can't say that a specific, like we did it with our lines up here, we can't specify an individual color. So we can't say that I want this line to be this color. All gizmos are now red, and if we want to change the color of that, all gizmos are now cyan. And this is how we have to change the color on gizmos. It's kind of weird, but it kind of makes sense. I don't know. I don't like the way that it works, but I'm sure that there's some magical reason why it is that way. Great. So the first thing we're going to do is we'll set this to red, I guess. And then we're going to say gizmos.draw, and we're going to draw a cube. Cubes are very, very simple. They just take a center and a size. So the center is going to be transform.position, and the size is going to be vector3.1, and that's it. So if I save this and I come back in here, we are now drawing a debug cube. So it's that easy to be, or a gizmo cube rather. It's that easy to draw gizmo stuff. It's not tough. You just have to do it in the right function, and you have to use the class to do it. And if we change this color to, say, cyan, like I was saying before, we come back in here. Once it reloads that script, this will be cyan. Bloop. It's cyan now. So, again, drawing gizmo stuff's not hard. So what we want to do is we want to make this a little more user-friendly, right? We want to be able to turn on and off the debug stuff individually and all that stuff. So we're going to say public bool draw gizmos. And I don't know, we'll make this one true by default. So if we're drawing gizmos, we want to draw this stuff. All right, that's pretty straightforward and easy. We've done this stuff before, right? So now we have this bool at the top up here that's going to provide us a checkbox, and we can turn on and off gizmos, right? Cool. Maybe we don't want to draw a square. Maybe we want to use all this debug stuff for every object in our game, but we don't want them all to be the same object. Well, now we're just complicating things, right? The best way we can do this is the way that I did it in the script, I think. The best way that we can do this simply is the way that I did it in my script, which was we have an enum. We have a public enum, or, well, actually, let's do this on the next line up. Sorry. Public enum, and we call these Gizmo shape types, and we say what we want: wire, sphere, well, wire sphere, wire box, sphere. We'll do solid sphere, and then we'll do solid box. So I don't know that I've ever used an enum with you guys before. I hope I have. Oh, I really hope I have. An enum is really, really simple. Oh, hey, it gives you definitions now. Oh, that's really cool. I didn't know that. This is the new mono develop, by the way. That's really awesome. I didn't know it gives you tooltips on stuff. Does it give you tooltips on everything? It does. Holy crap. All right, anyway. Enum is really simple. Look at that. It's that simple. Basically what it is it's a drop-down list for our knowledge. So over here on the right, which this is going to compile and is going to show you, well, it won't show you anything. Anyway, this is an enumerator as far as we're concerned. And I think that actually does come out to being an enumerator key codes. You can interpret them as enumerators, I believe. Anyway, this is effectively what an enumerator is going to look like. It's going to look like a drop-down list, and it's however many things we want to put in it is what it'll give us. But it acts like a function when we declare it. So this doesn't actually show up. What will show up is if we say public Gizmo shape types outer type equals new Gizmo shape types. So this will show us a drop-down list. This will not. This is effectively the things that are in our drop-down list, and we're just defining that for later use, if you want to think about it that way. That's usually how I think about it. So then when this compiles, we'll see that we get a slot added here, and now we have a drop-down list of those things we made: a wire sphere, wire box, solid sphere, and solid box. All right. So the next thing we want to do is we want to use this information when we draw our gizmo. So instead of drawing a cube, what we want to do is just get rid of that entirely. And actually, we're going to make another thing here for our outer object, because we're going to have an outer object and an inner object, so I can show you guys kind of the sorting of stuff and how that works. We're going to say public color outer color equals new color, or no, we're not going to do new color, we're going to do color.red. Color.red. Alright, so the outer thing is going to be red, and we also need a vector 3 for the size. Outer size, and this is going to equal, I don't know, new vector 3, and we're going to probably do 10, 10, and 10. Just to keep things easy. So it's going to default to 10. That way it's nice and big, and we can fit the inner one inside of it. That's the idea. And I think that's all we need for this. Oh yeah, we're going to need our Boolean for our matrix eventually, but we'll get there. We don't have to do that yet. Alright. So now that we don't have any, we're not drawing any gizmos anymore, we're going to do a big ol' if check for if, well, first things first. We're going to say, actually, let's have a public bool draw outer equals true. Sorry, I'm adding things as I go here. Alright, so now we're going to say if draw outer Now we can kind of, whoa. I was trying to save there. All right. Now we can have a toggle for just the outer one and just the inner one, because I like that idea. All right, so if we're going to draw the outer one, we're going to do a big old if statement here, and we're going to say if outer shape, outer type, sorry, equals our different types. So we're going to start off with we'll do a wire box first. And we're going to say gizmos dot draw wire cube, and the wire cube is going to be centered on transform dot position, and the size is going to be our outer size. It's pretty much that easy. But the other thing we're going to want to do is say gizmos dot color equals our outer color, because again we have to set our color, otherwise we don't have that. Alright, so we can test this already, but it's going to be kind of broken in the way that it works. So now we have all these new information here for the outer stuff. We have our draw outer, but it's defaulting to wire sphere, and because we haven't put any code in for wire sphere yet, that just doesn't work. But if we go to wire box, it actually does render our wire box. Oh, and it's kind of interesting. I believe F actually does use the gizmo constraints as well. It uses the whole bounding box of all the visual stuff. So if we change the outer size of this to like 1, 1, and 1, oh, and then we hit F. Oh no, okay, never mind. I was hopeful. It doesn't actually do that, but that'd be cool if it did. Anyway, point is, these change our size, and you may have noticed that like as we scale these down, these are actually the 3 axes of the cube, right? So that's cool. Yeah, I guess that's all I got. So, yeah. All right. So the next thing we're going to do is handle the next case, which can be whatever we want it to be. It doesn't have to be wire box. It can be, I don't know, it can be solid box if we want. But we're going to want to put an else after this, because it's only ever going to be one thing, and we don't want to run more lines of code than we need. So we're going to say if we're running a solid box, we're going to want to draw where is it? Draw cube. There it is. And it's all the same stuff, all the exact same information, because we're just rendering a box in a different way. So the next thing we're going to want to do is copy this line down, and we're going to say instead of solid box, let's do dot wire sphere. And instead of a cube, we're going to do a draw wire sphere. Now wire sphere takes some different stuff. It takes a radius instead of a outer size. So we can do a couple things here. I would prefer to change the way that we're doing this. So instead of being a vector 3, we're going to change this to be a float. And this float is going to equal 10. And then when we use that up here, because both of these take a vector 3, not a float, we're going to multiply this by vector 3.1. Whoa. Alright. And this is kind of not the best way to do this, but it's good for the example. The reason why I want to do it this way is because there's no good way to convert a vector 3 to a float, but there is a good way to convert floats to vector 3s, and that's by multiplying them by vectors. So what we can do, what this means is that we lose independent control of the size of each side of the box, right? So now if we want to run a wire box, being this is just a float, it's just an overall scalar for the thing instead of being more what we would like, which is I don't know. Instead of being more control, it's less control, but it's more universal for things that we want in our code, which is actually a pretty common theme in programming, I've noticed. Like, the more universally used it is, the less independently useful it is, which is kind of weird. But anyway, we're going to copy this down, and we're going to change this to solid sphere, and we're going to say dot draw sphere. And it takes all the same stuff again. So it's not anything different. So now what we have, if we grab our debug object here, now once our code down here is done compiling, we have all of the different options to draw all of the different things. Yep, it is that easy. So you'll notice that the solid sphere is bigger than the solid box. And the reason why is, so if I take the solid sphere, you'll see that it, like, that right there is what it deems as the size for it, because that's the radius. And the way that it draws the box is by the vertice points and not the, so there's our wire sphere, and there's our wire box. So you'll see that if you keep your eye right here on this vertice, you'll see that it, oh, what is it doing here? So this goes all the way out to 1, or all the way out to 10, I guess. And the box doesn't. It goes out to 0.5. So if we wanted these to be the exact same size, or rather it goes out to 5. If we want these to be the exact same size, we're going to need to take this and say vector 3 dot 1 times 2. And the reason why we do that is I'm not exactly entirely sure why we do that. It's kind of a weird, like, thing in the programming, I think, just in the way that it interprets. Whoa, that made it a lot bigger than I expected. Oh no, it didn't. Yeah, that's right. Wire sphere. Yeah. Okay. The reason why is because this interprets it as a radius, and this determines it as an overall width. So now they are actually true to be the same size. So the wire box and the wire sphere are actually the same size as far as their overall radius is concerned. The cube is going to be drawn at half the size because it's not considered a radius. It's just the side length. And then the sphere is interpreted as a radius. So of course the sphere is going to be larger than twice as large. As far as, like, volume is concerned, or, like, grid size. Anyway, that was a weird thing to try to describe, but that will get us our that gets us that. Great. So the next thing we're going to want to do is we're going to want to move to drawing matrix stuff. Do we want to do matrix stuff yet? I guess we want to do matrix stuff. Matrix stuff is kind of weird and confusing, but it's mostly because I don't know that I have a good way of describing what exactly a matrix does. Well, okay, I don't know how. I don't know that I'm going to come up with a good way of describing what a matrix is, but I do have a good way of describing what a matrix does. And what a matrix does is it easily converts between world space and local space, which I kind of talked about in the last video a little bit to greater or less success. But basically what we're going to be using it for is that rotation thing. So right now, I'm actually going to stop doing what I'm doing and show you. Right now we have this problem with our debug objects where, say we're using this sphere or this box to determine an area in which we are spawning things in, but we want to rotate it. Oh, it doesn't rotate. So we can't get, like, a rotated box. We can't, like, change the way that this is rotating. That's stupid, right? So how do we get that to happen? By using matrices, because right now Gizmo stuff is going to always be using world space for this object, and we need to make sure that that is not the case. So we're going to say public bool outer use matrix, and we're going to set this to true because we want it to always use local unless otherwise stated. And we're going to say if outer use matrix, we're going to set the gizmos dot matrix to the transform dot local to world matrix. So what we're doing is we're making it so that all of the gizmos, and keep in mind this is, I believe, is all of the gizmos in the game. So anything that is rendered after this is going to use this matrix. We're going to say that if we want outer to use matrix, we're going to set all the gizmos in the game to use its local world matrix. So it's local to world matrix. That's going to run its positioning and its rotation and its all that stuff the way that we want it to interpret that things through its own local to world matrix so that it will behave as we expect. For example, I know that that's a really bad way of describing it. That's the best I'm doing at the moment, though. So we have this little checkbox now, and now when we, well, I can show you with this wire sphere even. But you see that the sphere actually rotates with the object here. But if we turn that off, we'll notice that it doesn't. I can't actually select it by that. All right, we'll see that it doesn't. Now, if we check this, use matrix, there it is. And it's the same thing with our box, right? So if we have a solid box and we check this box, it'll actually make the box rotate with the object, which is really handy, right? So now if we, for example, we want this to be like a spawner for enemies, but we want it to be rotated a bit because say that there's like a column here or whatever, we want to avoid that column. There's a column over there, so we want to like nestle this between them. We can now do that. Well, we always could do that, but now we can visually demonstrate where the box is, right? Because again, this is all debug information. This is all being able to smooth over your designer process. So yeah. Great. So that's kind of matrices in a nutshell, and probably a poorly described way, but I'm hoping it's helpful and I'm hoping you guys are getting it. Ugh. Matrices are confusing, so sorry. Yeah. Alright. So the next thing we're going to want to talk about, and this gets kind of confusing. So this is our this is our outer area, which we're going to do an inner area, but first we're going to want to do another type of drawing gizmos. We're going to want public bool. Actually, no, wait. You know what? No, we are going to do this. So we want to basically do all of this again, but for a second set of gizmos, right? So instead of doing all of this twice in two different functions, we're just going to cut this and we're going to say public void draw gizmos, which, by the way, I don't believe that that is an inherited function. I don't think that that is a function that is going to be run by the engine. So we're going to take all this to draw gizmos is a bool that we have. Fine. We're going to say draw gizmo stuff. Boom, done. Perfect. All right. And this is going to handle all of our stuff. We're still going to have to do this stuff twice, but we're not going to have to here's the thing. We're going to eventually void on draw gizmos selected. Is that right? That looks right. Yeah, that's right. All right. So eventually we're going to want to do both of these, and instead of having to do this and then the next inner debug or gizmo stuff as well twice, like we're going to have to do this and then the inner one, and then that's all going to go in here, and then we're going to have to do it again. Instead of doing that, we're just going to have both of these call this when they need to. So we are going to make this boolean up here that I thought about. So we're going to say public bool gizmos selected equals true equals false. Yeah, equals false. I think that's a good way. No, we'll make it true. All right. So what this boolean is going to do. Draw gizmos. Yeah. Okay. What this is going to do is we're going to say if that boolean. Whoa. All right. If we're doing that, then we're going to draw gizmo stuff. All right. And we're going to say if... How did I do this before? Not draw gizmo selected. Oh, yeah, right. Okay, I can explain this in a second. Draw gizmo stuff. Cool. So on draw gizmos is called every frame, right? Every frame that we're running the editor and every frame we're not running the editor as well. So this is just run every frame in the editor. On draw gizmo selected is only run when we have the object selected. So this is really useful for, like, say you have 30 AI on screen and you have a bunch of debug information for them, but you only want the debug information to select on to show up on the one that you're currently selecting, so that way you can see, like, I'm looking at this guy, I want to see everything that's going on with him. You want to run all of your Gizmo stuff in here. Yeah, that's basically that. So this boolean that I have set up here is effectively going to toggle that. So if we're not only wanting to see when stuff is selected, we see it all the time. And if we are wanting to see stuff only when it's selected, it'll only show up here. So, for example, using what we already have, we have now a bunch of checkboxes at the top here. We have 3. And currently, all the debug stuff goes away unless I have the object selected. But if I uncheck this draw gizmos selected, now even if I have the object not selected, if I grab this camera, that object is still there. And that's, I think, a really important distinction to make, is that those two things are independently very useful of each other, and you can use both in conjunction with each other. So say that I wanted a sphere to be rendering all the time around all the AI, but I only want to see their line of sight stuff, or maybe I only want to see their line of sight draw lines. Again, this target line down here, this line target, that's how I do line of sight stuff, visualization a lot of the time. So say I want to see what they're seeing all the time, but I only want to see like their perception radius and like their pathing lines and things like that when I have them selected. That's the 2 ways to go about that. All right, so there's that. So anyway, the next thing we're going to want to do is make our second gizmo. So we're going to want to select all this stuff, and we're going to want to paste it down here, and instead of outer, we're going to draw inner. So inner, 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 and inner. All right, cool. And I mean, it's all the same stuff. There's not a whole lot new. As a matter of fact, we're actually going to just copy this, and we're going to do the same thing we just did. So this is going to be a little tedious to watch, but inner, inner, yep, inner, inner, what is to be inner size, inner size, blah. All right, and I'm gonna copy these across, save us some time. Yeah, there we go. All right, cool. So oh, that's not actually a thing. It needs to be capital. All right, so now we have our 2 different our 2 different objects being rendered differently. But here's the trick. So say that we have this one using the matrix, but this one not using the matrix. It's going to still use the matrix because, again, we've set all of the gizmos to use the world matrix already. So what we need to do is we need to say else gizmos need to use the default matrix. And I had to look this up because I didn't actually know what the default matrix was. What is it? That's right, it's equals matrix 4x4 dot identity. That's what it is. So that was kind of confusing for me to look up, but yeah, that's what it is. And then we're also going to do the same thing here. So because we this is just like a fallback check to make sure that we're always using the correct matrix. So if we want to use the matrix, then we are, but if we're not, then we are not. And this also works as kind of a setter for if we're like, if we are using the matrix here but we aren't here, that we make sure that we default to not using it, and yeah, yada yada. So yeah, I think that is everything. Oh, there was another thing with positions, I think, actually. Let me check this really quick and see if I am correct in thinking that. I'm looking over at my script that I already had written. You maybe saw me delete it, but you didn't actually see me delete it. Oh, we need to make that inner sphere a different thing. need to make this not red. Let's make it blue, just so we can see it better. And we reset. Let's reset. And we'll also make that not 10. All the things. 5 F. Alright, reset that, and now there we go. So there's our two different debug objects, and they're both using the matrix, but they all don't have to use the matrix. They can independently not use them. We can also draw them independently. We don't have to just have one. We can have both. We can have just one. We can have whatever we want. Outer doesn't have to use the matrix. Inner can use the matrix, so on and so on. But something that I believe is going to be the case is if I move this object over see this? This is not okay. But if they're not using the matrix, then they align just fine. And it's because the matrix, again, is a local to world transform change, right? So it edits everything that happens on the transform, which includes position. So what we're going to we need to actually change the way that functions, right? So we need to have a position setter. I think I only want to use one, so we're just gonna reuse one of them. We're gonna say Gizmo pose, and this is going to equal transform.position. And across the board, we're going to use this Gizmo position for all of transform.position stuff. So we're going to paste over all of that to use this. And then we're going to modify this if we are using a matrix. So if we're using a matrix, we also want Gizmo position to equal vector3.0. Now the reason why is because when we use this matrix, that matrix is going to interpret the position already. So when we move something, we're moving it doubly, effectively. So here, I'm going to redo that. This is going to compile, and it's going to work just fine, just like it used to be working. So as we move to here, I'm going to zero out those. So if we're looking at this from a top-down perspective, as we move to here, you'll see that it's moved double the distance, and it's like moving on a weird axis because it's rotated. Let me unrotate this, and it'll be a better example. We're going to do that. All right. So we're here in trying to get a decent view going. There we go. So you'll see the grid lines here. Here's a grid line. When I move to that grid line with the gizmo here, the handle, the transform handle, you'll see that it's going to move to here. So that means that it's moving it double the distance because it is using its local position and adding that to its world position. So as I move things around, it's going to move it twice that distance. That's what's actually going on there, because the matrix is telling it to do that, right? The matrix is saying, hey, here, use your local position. Oh, by the way, the local position and the world position are both happening, so use both. So what we need to do is we need to make sure that we reset that value if we're using the matrix. We set it to be world 0 so that we don't add two locations together. We're only adding the one location to the mix, and we're not confusing things. Likewise, we need to make sure that if we aren't using it, that we actually make sure that Gizmo position is indeed our transform.position, our world position. And we're going to want to do this for both of these things. So she's inner and outer. That's what I wanted to say. So we're going to take this, and we're going to do that. And we're going to change this from outer to inner. And that is that. Yeah. So now we have independent control over... Oh. There we go. And we'll see that it's... we can rotate this. And they are indeed using the matrix. And they are indeed obeying the correct position. And if we stop using the matrix on, say, the outer, it is still using the position just like the other one is. and we expect it to behave as it is behaving, which is fantastic. Exactly what we wanted. It's a little more complicated and meatier than I want it to be, but I prefaced this episode with the fact that it was going to be like that, so I don't feel too bad. And I think that's actually everything. I think that is absolutely everything that we had in our previous script. So we have lines, we have debug prints, we have all that stuff. Look at all that stuff we did. Wow. All right, cool. So what you're gonna see if you download this script, and hopefully this makes sense. And again, if it doesn't, if something in it is weird to you, or you have some weird question or whatever, absolutely 100% hit me up. Ask me questions, comments in the videos. I try to be good about getting back to people in the comments, or on Twitter. I will absolutely get back to you. That goes like straight to my phone, so it's scary information to relay to you guys, but well, not to you guys, but to the internet, I guess. That I get notifications on my phone for that, and I will respond as soon as I'm able to, through comments or through Twitter or through whatever. Shoot me questions, please. I will answer them. Or if I don't know. If you have suggestions for videos, yeah, absolutely. I'm always running out of ideas. But anyway, the script for this will be in the description below. So absolutely download it and try to follow along if you can, or just dissect it or use it as reference. I really don't care. Like I said, it's all debug stuff, and you can't make a game with any of this stuff. So rip it apart, reuse it, copy paste it. I don't care. But I'd prefer you didn't copy paste it, because that's not conducive to learning. But if that's your bag, that's your bag. Also, it's worth noting that when you get the script, it's going to have more stuff than this in it. I'm actually going to go through here, and I'm going to try to comment as much as I can in what I'm doing. So there's going to be notes in this for what all the stuff does. But yeah. So yeah, I think that's everything. Yeah. All right. Well, cool. Thanks for watching, and I'll see you in the next one. Bye-bye.